Hello. In this lesson, we're going to take a look at a different type of equation called a literal equation. By the end of the lesson, you'll be able to isolate a variable when solving literal equations. But before we do that, we have to figure out what a literal equation is. Well, a literal equation is simply an equation that involves two or more variables, different variables. So there's an example there that's a little more complicated than what we're going to deal with, but it's showing you what a literal equation is. 3xyz plus 9xy squared equals 325. I've got three different variables and I've got five total variables in this equation. And what we're going to be able to do is solve for one of those. All right. You might think that that sounds complicated. However, after a few examples, I'm hoping that you see that it's nothing different than what we've been doing. Why? Because to solve a literal equation, you use the same properties of equality that we've been using for the last few weeks. The same ones used to solve one-step, two-step, and multi-step equations. So let's take a look at an example. This equation, 10x plus 5y equals 60, is an equation used to show first of all, where x is the number of notebooks and y is the number of binders that you can purchase for $60. The question is, how many binders can you buy if you buy 3 notebooks? Could you figure this out by plugging this in and solving? Yes, you could. But what if I had 5 notebooks, 10 notebooks, and so on? Is there a quicker way? Could we solve this equation for a different variable? So what we're going to do is we're going to solve for y. Now, why am I choosing that variable to solve for? Well, the question is how many binders? And if you look back at what y stands for, y is the number of binders. So if I can get y by itself, I can plug a number in for x and get an answer to the question. So we're going to solve for y. Again, what does that mean? We want to isolate y, which means I need to move 10x and I need to move the 5. Well, which one do I move first? Undo the order of operations. I need to undo the addition first. So I need to subtract the positive 10x, which leaves me 5y on the left and 60 minus 10x on the right. Notice I cannot put those together to say 50x. 60 does not have an x, 10 does. Now I need to move the 5. I need to get rid of the 5 by dividing both sides by 5. And when I do that, the 5s cancel on the left, and I'm left with y equals, and I'm going to do 60 divided by 5, which is 12, and negative 10x divided by 5, which is negative 2x. Now that I have this equation, I can answer the question that I asked at the beginning. How many binders can you buy if you buy 3 notebooks? So if you purchase 3 notebooks, x is the number of notebooks, so I'm going to replace x with 3. So I have y equals 12 minus 2 times 3. What's 2 times 3? Well, that's 6. 12 minus 6 is 6. Y equals 6. Now, what does that mean? That means if I buy 3 notebooks, then I can buy 6 binders for $60. What about 5 notebooks? Do the same thing. You put 5 in for x. 2 times 5 is 10. 12 minus 10 is 2. If you buy 5 notebooks, you could only buy 2 binders. So that's one way where we will use literal equations. Let's look at another example. Looks like a little more complicated equation. 4pxz equals 7y. I've got 4 different variables here, but the only one that's really important is x. That's what we're solving for. We want to move the 4, the p, and the z to the right-hand side. Well, everything here is being multiplied, right? 4 times p times x times z. To undo multiplication, I'm going to divide. And what am I going to divide by? 4, p, and z. Anything that's being multiplied by x, I'm going to divide. I just don't want to divide by x. What happens is the 4 cancels, the p cancels, and the z cancels, and I'm left with x on the left. But then I have to divide the right-hand side by 4pz as well. And there's my answer. X equals 7y divided by 4pz. Formulas are another way that we use literal equations. A formula states a relationship among quantities. These are some very commonly used formulas in algebra, in math, and really in the world. So there's more, but this is just ones that you might have used before. So like the perimeter of a rectangle, P equals 2L plus 2W, 2 variables. The circumference of a circle, C equals 2 pi R, 2 variables. Area of a rectangle, and so on and so forth. Okay, so how are we going to use that? Well, we're going to rewrite a formula based on what we're looking for. what is the height of a triangle with an area of 60 square feet and a base of 10 feet? So the area of a triangle is 1/2 base times height. We want to solve for h because we're looking for the height. Well, how do I do that? Well, I need to move the 1/2 and the b. How do I move that 1/2? Remember how we cleared fractions in a previous week? That's what we're going to do. We're going to clear the fraction by multiplying both sides by the denominator, or 2. So that cancels the 2 on the right, and I'm left with 1bh, or just bh, equals 2a. Notice I'm leaving the variable capitalized because that stands for area. Minor detail, but one that I do want to point out. Well, finally, I'm just going to divide by b to get h by itself. Cancels the b, and I'm left with h equals 2a divided by b. Now I can plug in the known variables to find the height. So I know the area is 60 and the base is 10. Now I just simplify that expression and I have my answer to the question. 2 times 60 is 120, divided by 10 is 12. So the height of the triangle is 12 feet. Okay, and that concludes today's lesson.